It is now time to attack one of the big areas of your S3 training. On a topic you've already studied and may or may not have found tricky on S2 level. On S3 level, we elevate this. This is the slightly complex world of separation. You have already learned a lot about separation on S2 level. Now, what did you learn again? Route separation, performance separation, wake turbulence separation, parallel approaches, all this. And it's in some way incorporated into S3 level as well. However, you need to look at it quite differently. There are really more conditions to an entirely different way of providing separation rather than actual requirements themselves. First of all, we collected under a nice big tree, which is called radar separation. This is what you provide from your radar scope where you can see everybody. This is also one of two trees, so to speak, a radar separation tree and a procedural separation tree for those places that do not have radar. This, though, is a topic for your Tier 2 endorsement. Secondly, you may remember all the S2 separation on the ground were given in minutes. Now, you can go ahead and throw the whole minute thing into the bin. We don't deal in minutes doing radar separation in the air. They are given in nautical miles. That's the first big lesson. Now, let's dig into all the kinds of separation there is. Let's, so to speak, explore the tree. I will try to explain this as intuitively as I can. From the root emerges two ways of separating, because, welcome to S3, you have earned an extra dimension to separate in, horizontal and vertical. And let's begin with the horizontal one, and at the base of this is the separation, which is the one that applies to everyone, regardless of place, performance, weight, color, catering, textile, no matter what. Into EASA Part ATS TR 210 concerning radar separation. You also see that this so-called separation for everyone has a few asterisks, but in general, unless otherwise prescribed in accordance with point B of AMC 6 and AMC 7 and ATS TR 255, the horizontal separation minimum based on radar and on ADSB and or MLAT should be 9.3 kilometers or 5 nautical miles. That's the one. Separation at all times, regardless of anything else, must be 5 nautical miles or greater, unless 1. 5.6 kilometers or 3 nautical miles when radar and or ADSB or MLAT systems capabilities at a given location so permit. What does that even mean? That's a nice vague way and open to interpretation. So we go a step up in our documentation, from EASA to the National ATS Instruction 10, the ATS monitoring system, where it will be a bit of a documentation journey. 1392 stipulates that if approved by the Danish Transport Authority and stated in local ATS instructions, which it is, the separation minimum stated in point 621 may at altitudes below level 195 and in compliance with point 611 be reduced to 3 nautical miles in more precisely defined areas, provided that the aircraft involved are under speed control by the air traffic controller and or in accordance with the local procedures as stated in the AIP and limited to the maximum of 250 knots indicated airspeed. Note: conditions for establishing more precisely defined areas can be set out in Appendix A, so down to Appendix A we go. First section, here in Appendix A, is concerning reducing separation to 3 miles, which apart from a lot of real-world blah blah blah, includes that the area is within 30 miles of the radar station antenna, which means basically all TMAs in Denmark, because all radar-controlled airports in Denmark have an antenna at the field. Remember back to your airspace structure lesson, while a TMA are within 30 miles, the CTA airspace may be more than 30 miles from the airport, so don't forget that this 3-mile separation is not applicable in that airspace. Neither at speeds above 250 and altitudes above level 195. Just a minor detail. Read this ATS instruction for its full understanding if you can. So, long story short, the 3 nautical miles is applicable to all TMAs in Denmark, because you are always within about 30 miles of your airport. Hence, the so-called minimum of 5 miles is now actually for S3, 3 miles. That's a separation that may be used in our TMAs. 5 miles is standard, 3 miles in the TMA, and it actually goes even further back in the EASA Part ATS, because next it says, and 4.6 km or 2.5 nautical miles between succeeding aircraft which are established on the same final approach track within 10 miles of the runway threshold, a reduced separation of 2.5 nautical miles may be applied, provided, and then there is a long list of what needs to fulfill this. This is a special case known as reduced separation procedures, and in Denmark currently only in use at Copenhagen Airport, and therefore a thing for your Tier 1 endorsement later on. No need to worry about that for now. So we learned what we needed here. 5 miles between everybody except in approach airspace within 30 miles of the radar station, below level 195 at 250 knots or less. In this case, it may be as low as 3 miles, and only with approved separation procedures as low as 2.5 miles. Good. That's the essence of the radar separation and the first branch of our tree. Now, not only do we have this compared to S2 level, we even have the luxury of an added dimension, because if we can't maintain the horizontal separation, we must have vertical separation. Now, what is that now? Well, it is that if the horizontal separation cannot be maintained, a vertical separation of minimum 1,000 feet is required from the MSA and upward to flight of 285. From 285 to 410, it's also 1,000 feet if you have RVSM airspace, which is called reduced vertical separation minima. Above that, 2,000 feet is required. Both these are C1 topics and shall not be discussed further here. You can read up on that yourself. Let's focus on the standard vertical separation. This means that you can achieve an alternate form of separation by having aircraft 1,000 feet from each other. There's also a tolerance of 300 feet above and below its assigned altitude. This is per part ATS TR 155 and stating that in accordance with the AMC ATS TR 155, the criterion which should be used to determine specific levels of occupied aircraft should be plus minus 200 feet in RVSM airspace. In other airspace, this criterion should be plus minus 300 feet. Now, how do you go about this vertical separation? There are rules on this, and it seems to confuse many students and controllers alike of how this may be used. So let's just get this settled via EASA Part ATS once and for all. ATS TR 210C, except for areas of operations on parallel and near parallel runways referred to in point TR 255, or when a reduction of in-separation minimum of the scenic aerodrome can be applied. Separation by an air traffic control unit shall be obtained to least of the following: horizontal or 1. Vertical separation. The vertical separation minimum shall be the nominal of 1,000 feet up to and including flight level 410 and 2,000 above that level. So when one aircraft is occupying a level, another aircraft may not occupy that level, right? Now, what does occupying a level mean? Oh, good, we have acceptable means of compliance. So as per AMC1, an aircraft is considered to be maintaining its assigned level as long as the pressure altitude derived level information indicates that it is within appropriate tolerances of the assigned level. That's the 300 feet we were talking about. And here's all kind of things. B. Aircraft vacating a level. An aircraft cleared to vacate a level should be considered to have commenced its maneuver and vacated the previous occupied level when the pressure altitude level information indicates a change of more than 300 feet in the anticipated direction from its previously assigned level. On D, an aircraft passing a level in climb of descent. An aircraft in climb of descent should be considered to have crossed the level when the pressure altitude information indicates that it has passed the level in the required direction by more than 300 feet. What did we just read in these two sections? The implemented rule and the acceptable means of compliance. It means flight level 90, when you're maintaining it, is occupying level 90. Maintaining level 93 is occupying level 90. Descending reaching level 87 means occupying level 90. Reaching flight level 86, however, flight level 90 is vacated. Reaching flight level 84, aircraft is still descending. Reaching flight level 83, however, flight level 80 is now occupying. And then onwards, reaching level 76, then flight level 80 is vacated. This means that this guy at level 110 and this guy at level 120, when the first guy reaches level 106 and descending, level 110 is considered vacated and a descent to level 110 may be given to this guy on top. It does not mean, though, that you can descend this guy from, let's say, level 190 to level 90, and then when he's at level 186, you say, yeah, okay, I'll descend this guy to level 80. No. That's not how this works. All levels a descending aircraft is passing must be ensured clear of traffic. Instead, what you can do is descend this first guy from level 190 to 90, and then when he passes, let's say, 146, you can descend this guy to level 150, because all the levels he will pass is ensured clear. Just an example. Hopefully that is fully understood. Don't let me see you make that mistake. This should be clear as day. Now we have vertical separation out of the way. So let's return to horizontal separations, because there are still a couple of branches to be covered. This is in regard to handing over an aircraft to another controller. It's sort of a route separation, and it is a legal separation requirement in accordance with both EASA and local procedures. You see, guidance material to Part ATS Tier 155, as well as our LAIs and LOAs, explains nicely that B, the minimum distance following successive aircraft during the period of transfer, is agreed as one of the following values: 10 nautical miles when SSR information is used in accordance with provisions, provided that an overlapping radar coverage of at least 30 miles between units exists. This is generally what you need for all transfer in Denmark, 10 mile spacing, with the leading aircraft being faster than the trailing. You can reduce it, though, to 5 nautical miles when the conditions of point B1 apply and both units involved possess electronic aids for immediate recognition of release and acceptance of aircraft under radar transfer. The specificities of this is highlighted in each individual LAI and LOA for each coordinating sector. So, to make complicated talk more simple, you have two different values for horizontal separation when you're handing over to another sector. 10 nautical miles if you want to do it silently via the gyroscope transfer function, or 5 nautical miles if you have prior coordination and consent from the receiving sector. Now, let's get back to our tree. I want to introduce another branch because there is another not talked enough type of radar separation you should learn about. Well, you have learned about it before actually. It's wake turbulence separation. You remember you were doing all these sorts of minutes between departures, but there was not really anything for the arrivals, were there? But of course there is. But like you as tower provide wake turbulence separation for departures so that approach don't have to do it, it's exactly opposite for arrivals. Approach applies wake turbulence separation for arrivals, so tower don't have to think too much about it. It's with the exception of two types as per the AMC to TR 220. It is VFR flights and flights conducting visual approaches maintaining on separation. Apart from these two, wake turbulence separations must be provided for all arrivals. Part ATS in TR 220 have an implemented rule that the application of wake turbulence needs to be based on 1. Aircraft flying directly behind each other within 1,000 feet. 2. Operating to same or parallel runway. 3. Crossing within 1,000 feet. While this is given in minutes for AMC2, there's also AMC6, which denotes the separation you must provide as approach, given in as a radar separation in nautical miles. As you see, there is all sorts of information, but let's try to simplify it in operational terms. Standard separation was, we've just learned, 3 miles, or reduced separation that can be applied in Copenhagen, then it's 2.5. That is the base if no wake turbulence separation is needed. From there on, it can be 4 miles, 5 miles, 6, 7, 8. So as you can see, slightly more complex than S2. The logic is quite similar though. A light behind a light, a medium behind a medium, that's just standard. If the preceding aircraft is of a heavier category, then we need different mileage. It's logical enough. Let's go. A light behind a medium behind a heavy, we need 5 nautical miles. That's an important one, and it is by far the one that's used the most. But now there's even wake turbulence separation between two heavies, which is 4 nautical miles. So a heavy behind a heavy needs 4 miles. If you go 2 categories up, there is also a penalty. A light behind a heavy is 6 miles. So standard 3 nautical miles, heavy behind heavy 4 nautical miles, lighter behind a heavy category 5 miles, light behind a heavy, so double category up, 6 miles. These are the main ones. And then of course, there is the super category for a good old A380. 6, 7, and 8 nautical miles. For heavy, 1 category below, medium, 2 categories below, and light, 3 categories below. And this is a little more rare. These two here, these two are the ones you will be using by far the most often. That was the most important points on separation. I hope you are not completely lost on this complex topic. Otherwise, watch this video again and study the material extra carefully. Horizontal separation of 5 miles, normally 3 within 30 miles of the airport, 2.5 only when specifically approved through the LIA. 10 miles for silent handovers, 5 for coordinated handovers, a variety of separation for wake turbulence, 1,000 feet vertical as well as an RVSM, 2,000 above level 410. Lots to learn, lots to study. Make sure you have complete ownership of this. You cannot survive your S3 not knowing this essential stuff. Good luck moving forward, keep that spacing, and thanks for watching. Class is dismissed.